My presentation is about normalizing state and React applications. It's a state management concept, therefore it's talked about in Redux documentation because it can reduce the complexity of reducers that you write. But it's more general of a problem than that. It's not a concept that's tied to Redux in any way because it's a state management concept. So whether you use Redux or not, state normalization can help. And I'm also going to extract a principle out of it to show how this same concept can help outside of a React application as well. So I'm going to use this example problem of airtoast to show how state normalization works and how it can help reduce complexity in an application. So let's say that we have these airtoasts that have these requirements such that the messages are unique and the bullet points are updated through that message. So in other words, if another password is invalid error happens, instead of creating a new toast with different bullets, we update the existing toast with new bullets. And to accomplish this UX, we would maybe create an API that looks like this, where we set toast on message with bullet points and then remove toast through that message. So we'd probably be thinking to ourselves when we go to implement these toasts, first we want to create the shape of the state to represent these toasts. And we'd be thinking, well, we have a list of toasts on screen, so an array of toast objects makes sense intuitively to represent those toasts on screen. So we'd probably create a shape of state that looks something like this. Now, given these requirements and given the shape of state, the setToast function will need to scan the whole list to see if the toast exists, replace it if it does exist, and add the toast to the list if it does not exist. So there's a fair amount of complexity there. Remove toast isn't too bad. It's just a filter to where the message doesn't match. So I want to focus on the complexity of setToast. An implementation of setToast might look something like this, where we're looking for to see if the toast exists and keep a reference to it. If it does exist, then the mapping will be where we map the existing toasts except for the one that does match, and then we replace that one. And then if we were unable to find that toast that matches that message, then we spread the existing toast and add this new toast. So there's a fair amount of complexity here. We've got a find and some conditional and two different types of mapping here to create that updated state. I'm going to suggest that there's a much simpler way of doing this. And the shape of our state, though it may be the most intuitive, is actually wrong. And the reason why one reason why anyway, is that the shape of this state does nothing to enforce the requirement, specifically this requirement of having unique messages. Because as you can see, there's nothing here that enforces the message to be unique. That has to be done through the implementation. And also, we're identifying these toasts through that message that's not guaranteed to be unique. So what if we were to normalize this state? Not necessarily normalize the entire state, but just normalize it to message. That might look something like this, to where instead of an array, we have an object whose properties, or I'll call those keys, are that unique message. And now, by way of them being properties in an object, they're required to be unique. And also, our implementation no longer needs to enforce that requirement, and it also has an easy way to identify the thing that wants to update because it has a reference to that unique thing that wants to update. Hence, our implementation is nothing more than a very simple single spread operation, and remove toast has even been simplified. It's now the exact reverse destructure operation. So the point is, you have a normalized state if all of the props in your state tree are keys, they're IDs. They're not indexes. Here's an example of a normalized state from that Redux documentation. And you could be surprised to see that we still have arrays. The reason that we still have arrays is because arrays have the concept of order and objects do not. So if you have a use case for order in your state, instead of putting the objects inside of an array, what you do is you just take the key of those objects and put those keys in an array. So you can say that if these objects are supposed to be expressed in a specific order for any use case, then you put the order of those keys in an array for that use case. Now, the other thing you may notice here is, just like in our example where we showed how the state management can be simplified through normalization because it becomes a spread operation or a destructure, you'll notice everything in here can be done through a spread operation, except for the arrays. The arrays, if you express order of keys, you probably want to treat those as treat that whole value as treat that whole array as a single value, and therefore all IDs is its key, or post dot all IDs is its key. So everything should be treated as a key, and if everything is treated as a key, then reducers are only ever going to be spread operations or destructure operations, and they may be nested, but they're still just structure or spread or destructure operations, and hence should be much simpler because you don't need to do any conditionals and all sorts of weird mapping and stuff. You should be able to just do it with the spread and destructure operations. So really, the principle I want to extract from state normalization is that you should identify the thing you want to update by key, not index. And the reason why is indexes change and keys do not change. Here's an example of that principle at work in Mongo and Redis. Now, Mongo and Redis have got a very similar concept to each other. They just give it different names. Mongo calls this concept dot notation, and Redis calls it JSON path. And they're basically these strings that describe how to navigate from the root of an object to anywhere in that object, and for the purpose of updating it. So they both have this set API, and I'm kind of paraphrasing this API, but they both have basically this set API that takes a JSON path and a new value. Now, in this example JSON path here, if this number here is an index, then if the order of users changes at all for any reason, including just adding a user before this index or removing a user before this index, then you're going to update the phone number of the wrong user. However, if this number here is an identity of a user, a key, then you're guaranteed to update the right user no matter what, every time. There's no race conditions or anything. So state normalization offers this guarantee that you're updating the right thing and reduces the complexity and reduces the possibility of race conditions and things of that nature. So we've talked about how state normalization can reduce complexity and also add to reliability in our state management, and also out in the persistence layer as well, especially if you're using Mongo or Redis. Also, the exact same principle holds true for diffs, because inside of diffs, they call out locations of a model with new updated values for those locations. So you could write them with a JSON path. It doesn't really matter. Just whatever that is in a diff that calls out a location in a model, if there's an index there, you stand that risk of identifying the wrong thing, and which introduces the possibility of race conditions, or at the very least introduces complexity when you go to execute that diff. Now, this principle is also used in React itself to solve a problem. And the problem it solves, I'm going to illustrate here, where we have an array of objects that we're mapping to components. Now, when you do an operation like that, when you map objects or map an array of anything to components, what you're really doing is you're mapping this array of objects to component instances. And those component instances live longer than that render. So in other words, on a next render, if the key prop was not given a valid key, or is just given an index or not defined, what ends up happening is, even though your object array has been given a different order, the component instances are still in the same order. And so you end up having this mismatch situation where you're passing different nodes to different component instances. And those different component instances have different state, different refs, represent a different place in the DOM, which could have a different control focus. And so the thing I'm trying to illustrate here is, even though this may not seem like the same problem that Redis and Mongo is solving with normalized state, it actually is exactly the same thing, because the problem that we solve with normalized state in Mongo and Redis is that we're guaranteed to update the right thing because we're updating on key instead of index. In React, we're updating the right component instance because we have a proper key, not an index. So when you give React a key, these component instances are added and removed and sorted based on that shared key with the objects that they represent in that array. So in both cases, it's about updating the right thing, and that guarantee is there because it's identified on a key instead of an index. In other words, it's things are identified based on what they are instead of where they are. So I want to get back to how state normalization can reduce complexity inside of our state management. And yeah, spread operations are, if you only have to do spread and destructure, it's much simpler than having to do all sorts of conditional mapping. Even in that very small example that we saw earlier, had a bit of complexity to it, even though it was very small. We still had conditionals and different types of mapping based on those conditionals and so forth. And if you have normalized state, you don't need to do any of that. All you're doing is spreading or destructuring, or a combination of the two. Now, I would say this set state callback that could have been written as a reducer, it knows how to update this single and exact JSON path in a model. And as you can see, it's still fairly complicated because we've got nesting and we've got null checking or undefined. It's completely coupled to the model, because if the shape of the model changes, I need to rewrite this, and it's not reusable because it only knows how to update phone number. So even with this simplified state management, it's still complicated. We need to change it often, and there's a lot of it, which is not great still. It could be much worse, but it's still not great. So I'm going to say, well, Mongo and Redis don't seem to have that issue because they have a really clever set API that works on JSON path. What if we had a similar API, but instead of mutating the model, it will actually create the next immutable progression of that model that has that update in it. So instead of writing all of this nested spreading and null checking and all that stuff to where if any of the JSON path is missing, it'll build up the proper object and spread that in with all of the original references maintained except for the updated ones. What if we just had a set method that took care of all that complexity for us declaratively? At this point, it's no longer complicated. It's just the single fluent statement. And it's no longer coupled to the model because we can just change the JSON path if the shape of the model changes. And it's completely reusable because, again, we can just change the JSON path. This exists in an NPM package I wrote. And I went into this NPM package just with the purpose of state management and validation. And as it turns out, state normalization can help in a lot of ways, is what I've learned. Because I went through it thinking like, well, okay, what if validators just know how to validate a certain value, and you could attach many validators to any JSON path in a model? That would be a very cool way of approaching validation, because then you have a validation model that automatically mirrors the shape of your model, and it's no longer coupled to the model. And at the same time, diffs become really cool because if your state is normalized, when you run a diff from one state to another state, the diff it produces is also normalized and can be sent directly to persistence, or you can wrap your diff with authorizations on the backend and so forth. And then the concept of backwards compatibility also becomes very simple to deal with, because at that point, if you have these JSON paths in normalized state, you can you can just say that the previous version of the model is this other JSON path, so backwards compatibility can just be expressed through an ordered list of JSON paths that express previous shapes of that model that it can work with. I'm not explaining these things properly, but the point I'm trying to make with this is not to plug this NPM package at all, because I'm not even going to go into detail about how this package works. The point is that JSON, or that state normalization greatly simplifies our code, and at the same time makes our code a lot more simple. And therefore, we should normalize our state, because I've seen that play out in so many ways, just by normalizing state and then which allows me to take advantage of JSON paths and all sorts of other concepts. And at the very least, reduces the complexity of our state management, and also adds a lot of reliability, because even in a React application, you could run into race conditions, because we do have a lot of asynchronous events and things that invoke our state management. So anyway, the point is that normalized state can make our code simpler, more reliable, and we should normalize our state.